Hello, I am Lady Laghangam, course GE4264 from BS Criminology Department. I have here the topic of geometric transformation. So later we will going to tackle or discuss the different types of transformation. Geometric transformation. Learning objectives. By the end of this lesson, students should be able to first identify the different types of transformation categories, describe the three types of transformations, discuss and draw real-life examples of transformations. Reflection. A reflection can be thought of as folding or flipping an objects over the line of reflection. The original object is called the pre-image and the reflection is called the image. The image is usually labeled using prime symbol with such A, B, C. An object and its reflection have the same shape and size, but the figures face in opposite directions. The objects appears as if they are mirror reflections with right and left reverse. A reflection can be seen, for example, in water, a mirror, or in a shiny surface. Take a look at the following reflection. So the first photo is the reflection of water. The second is the woman reflection in a mirror. The third photo is reflection in shiny surface. Second is rotation. A rotation is a transformation that turns a figure about a fixed point called the center of rotation. An object that its rotation are the same shape and size, but the figures may be turned in different directions. Rotations may be clockwise or counterclockwise. Rotations can be seen in a variety of situations. Amusement park swing. Amusement park rides such as the swing allow you to become part of a rotation. Ferris wheel. Ferris wheels rotates about a center hub. Merry-go-round. On the merry-go-round, riders become part of the rotation about the center of the ride. Next is translation. In a translation transformation, all the points in the objects are moved in a straight line in the same direction. The size, the shape, and the orientation of the image are the same as that of the original object. Same orientation means that the object and image are facing the same direction. Every point of the object is moved the same direction and the same distance to form the image. Translation can be seen in a variety of situations. Translations can be seen in a nature. The hexagonal sections of honeycomb are the same size, the same shape, and face in the same direction. Second photo, as you go down a slide, you are undergoing a translation. You are moving a given distance in a given direction. You do not change your size, shape, or the direction in which you are facing. So that's all. I hope you get something in this short discussion. Thank you.
Hello guys, I'm Trisha May Luna from Group 4. The topic that I choose is patterns and diagrams. It's part of the geometric designs. Patterns and diagrams. Patterns are one aspect in geometry which are usually found and utilized. As we can see, there are patterns around us. Example is in our home. We see patterns on wallpapers, windows, floor mats, and even on pieces of furnitures. And also patterns are profusion on nature, on flowers, leaves, and even on animals and other places. Symmetry. According to Hermann Weyl, symmetry is one idea by which man through the ages has tried to comprehend and create order, beauty, and perfection. Symmetries are an integral part of nature and the arts of cultures worldwide. It can be found in architecture, crafts, poetry, music, dance, chemistry, painting, physics, and mathematics. Symmetric designs are so naturally pleasing. Symmetrized symbols are very popular. Reflection symmetry is also called a bilateral symmetry. Example of bilateral symmetry are flatworms, clams, snails, spiders, and insects. The reflection line is called the line symmetry. If a figure can be rotated about a point in such a way that its rotated image coincides with the original figure, then it is called rotational symmetry. The angle of rotation of a symmetric figure is the smallest angle of rotation that preserves the figure. Then, the order of rotational symmetry of a shape is the number of times it can be rotated around a full circle and still look the same. Next is rosette pattern. The symmetry groups have all been 1 to 2 types: cyclic symmetry and dihedral symmetry. Cyclic symmetry occurs when the geometry loads, constraints, and results of a partial model can be copied around an axis in order to give the complex model. Example is a fan blade. Next is dihedral symmetry. Group has rotation symmetry, and if the rotation has n order, there will be n reflection lines, and the group is called d over n. Rosette patterns have been used as architectural and sculptural decoration of the new century. Next is frieze pattern. An infinite strip with a repeating pattern is called a frieze pattern or border pattern. The term frieze is from architecture. Mathematician John H. Conway also created nicknames for each frieze group that relate to footsteps. Next is tessellation. Tessellation is defined as a pattern of shapes that covers a plane without any gaps or overlaps. There are 3 types of tessellation: translation, rotation, and reflection. The vertex point is the point where the shapes come together. Example in tessellation of triangle, the number of sides is 3, and their 6 shapes is 3, 3, 3, 3, 3, 3, 6 trees. For the squares labeled as 4, 4, 4, 4, and for the hexagon we can call it 6, 6, 6. Then semi-singular tessellations can be formed using a variety of regular polygons, and the arrangement of these polygons at every vertex is identical. Examples of semi-singular tessellations. And also tessellations can be used to create art, puzzles, patterns, and designs. And that's it.